video, we are going to discuss about 4-bit synchronous up-down counter. So for this one, you go to File, click New Project, then click Next. Then this is a project 12 is my title, RTL project. Click Next, choose basis board, then give Finish. Okay, then go to Add Source, Add or Create Design Source. You click the first program as counter. Okay, counter program. So give OK. Finish. Okay. So you click this counter program. I have already done this counter program. So you can see module name, then clock, reset, UD, load, data and count. Okay, the inputs are clock, reset, load and UD. And you have input as 4-bit input as data and 4-bit output as count. Okay, so always at the positive edge of the clock. If reset is 1 means the count has to goes to 0. It is a 4-bit counter, so the 4-bit values also it goes to 0, else it will come to load. So if the load is 1, I can give this data. From the data it will start counting. The count it will be reflected in the output. The data, input data will be reflected in the output. Make sure that input data and output are of 4-bit. Okay, else if UD is 1, okay, if UD is 1, start to count up. This is for up counter. If UD is 0 means it will down count. Okay, so this is what the program. I am going to copy this program, entire program, and paste it here. Then save this program. Then click run synthesis. So it is running this program. Once it start completing this run simulation, okay, you have to go for the add or create simulation source. You click next, create file. Okay, I giving the name as test. Okay, I give OK. So inside this one you have the you have to write the test bench program. What is test bench means? You have to give the input and you have to verify the output, right? So this is a program for test bench. Okay. So what is a program means? A module test. Instead of input you have to give it as register, and instead of output you have to give it as wire. Okay, so you have to call that program. So the counter is the name that I have given. Okay, you can check it out. This is a counter program, so you call that program, give the name. So this clock, reset, UD, load, data and count representing this one. And it will be this clock, reset, UD, load, data and count represent the counter program. Okay, so initial begin if clock is equal to 1. Okay, for after the 5 nanosecond it will be 0. Okay, so initial begin if reset is 1 initially, and after 10 nanosecond it becomes 0. Okay, so initial begin, then load is equal to 1, so load is equal to 0, and after 20 nanosecond the load has to be 0. Okay, then initial begin UD is 1. If UD is 1 means it started to up count, right? So after 30 nanosecond it will be 0. After 100 it will be 1. Okay, then initial begin data, the data is 000. Okay, initially the data will be 000. Okay, then you can monitor this using this line. Okay, then I'm going to save this program. Okay, then I'm going to click run behavioral simulation. So if you see, so initially the reset value is 1 up to 10 nanosecond. This is what I have written. Okay, reset is 1 up to 10 nanosecond. Okay, after that the reset is 0. So if the reset is 1 means the output must be 0. Okay, output must be 0. Okay, output must be 0. So after 10 nanosecond, the reset goes to 0. So if UD is 1 means it will start to up count. Okay. So after 0 you will get 1, then 2, see. After 1 you will get 2, 2. Okay. So after 30 nanosecond, what is going to happen? After 30 nanosecond, UD becomes 0. So if UD is 0 means it will start to down count. So it will goes to 1, okay, then 0, then F, F, E, D. F represent 15, okay, E, D, C, B, A, 9, 8, 8. Okay, so you can see here since the UD is 1, it start again to up count. Okay, it becomes 9. Okay, 9 A, B, C. Okay, so it is working properly. Okay, so next click the source. I need to implement this program. So in order to implement this program, I have to write the program for clock divider. Okay. So this is a program for clock divider. You just copy this program. So you save this program. Okay. So if you want, you can run the synthesis. Okay. So again, I'm going to create the top module. Okay, for this program. So I click this top module. So you can copy this program for top module. So you can see module top input, you have to give wire. Okay, clock in, reset, UD, load, data and counter. So you have to write the wire clock 1 hertz. Okay. So in the clock divider program, you have a clock in and clock out. Okay, initially. So this you have to convert it into clock in. Okay, clock in. Then clock 1 hertz. Okay. So the clock in, clock out represent input and output of clock divider, and clock now it becomes clock in and clock 1 hertz. Okay, clock in of this top module and clock 1 hertz of wire. Okay, then this clock 1 hertz is going to the input for the clock. Okay, so the clock 1 hertz reset, everything is same. Okay, so you save this program. So now the top becomes a top module. So this is becoming a top module. Okay. Okay. Next you have to create the constraint file. Okay. So top constraint. Okay. So you click this constraint file, you copy this constraint, so you save this one, then you can go for generate bitstream. So we can see in the top right corner it's running. Okay. So in this you can select, if you refer my previous video, you can see this L1 as these are my outputs and these are my input pin. Clock in, you have to give it as W5. Okay, must give it as W5. Okay, then reset I am going to give it as W16, W17 and W15. Okay. So now it start completed the sum. Then you click open hardware manager, then click open target. Okay. Very well. Then click open target, auto connect. Okay, program devices. So you can see the top dot bit that you have to program. So once if you program, you will get the output. Okay. So initially it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so here you can see this this UD pin is turned up, right? So if I make this pin as a down counter, it will count in the down count. It will act as a down count. So now if I make this W16 pin, this is my W16 pin. If I make this W16 pin as 1, it will goes to 0. Okay, since it is a reset pin. Then if I make this W16, okay, and I can give from W17. So this is my W17 pin, which is a load pin. Okay, so this is my load pin, and these are my datas. Okay, data pin. Okay, so according to my program, okay, if I load this pin, okay, then if I make this load as 0, okay, it will down count. Okay, from this it will start to down count. Okay, so it is down counting. Then if I want to make this as up counter, I have to turn on this W15 pin.